Hi, my name is David Abramowitz. I'm a regional technical lead with Trend Micro. Welcome to my session, Knocking Down Tech Silos to Deliver Cloud-Based Social Services. So today I'm going to talk about three things. Number one, the project background. What was it that brought this project to light? What were the circumstances? A bunch about the implementation, including the solution they chose, but also what they were looking for in the solution, how they implemented it, and how it integrated with AWS. And then I'm going to wind it up with lessons learned. So let's jump right in and a little bit of background on this project. So in this particular city, there were riots going on. And while a man was in police custody, he was killed. So that sparked off a round of protests, which then led to much unrest. And that led to violence, and then a lot of people needing a lot of help. So the state looked at this and said they were scrambling. They didn't really know how to get the services to the people who needed them the most in an efficient way. There were so many agencies, so many people with different systems, different procedures. There was no clear way to get things done in a very efficient manner. So one man came up with an idea for a statewide cloud platform. They wanted to modernize this, make it cloud-based, and they wanted to build it upon AWS. So they wanted a system that could be accessed by any agency throughout the state. And no matter what was needed, this one web portal would be the starting place for somewhere to go to get the resources and to point them in the right direction. So in terms of the requirements set out, generally they were looking for, number one, scalability. And that not only means scalability in terms of AWS, which we know is very scalable, but also in terms of the security solution that they chose. In other words, if I'm spinning up an EC2 instance in AWS and all of a sudden there's a tremendous demand for more EC2 instances, I want the system that's securing this thing to respond in kind. I want to see in that console that these several hundred, let's say, instances have been spun up suddenly. And when they're spun down in AWS, I want it to also reflect in that application. Flexibility. So I want to be able to protect multiple platforms. I want to be able to use a single agent to do that. And I don't just want anti-malware, because there are a lot of needs specific to servers and cloud workloads, and I would like those addressed too. And of course, affordability. So give me the flexibility also includes some pricing models that make this affordable for me. And I have multiple models to choose from, whichever fits our requirements. I want that flexibility as well. And of course, uniform security. So it shouldn't matter whether I'm protecting a Windows instance, a Linux instance. Doesn't matter if the operating system has been sunsetted by Microsoft and is no longer getting patches for vulnerabilities. I need you to protect me fully in those environments. I would like it not to matter if that instance is a server, a physical server on-prem, a virtual server, or a cloud instance. I want the security to be uniform. And oh, by the way, I would like to do it with one single agent. And those were the requirements up front. Specifically, the security for Windows and Linux, again, not just anti-malware. So what are the needs of a server or a cloud instance that make it very different from a desktop or laptop? Well, there's no one sitting there performing functions generally like a user would behind a desktop or laptop. There are several things of interest on a server, whether it's SQL server, a database server, a DNS server, multiple jobs that a server can have. It shouldn't really matter for the security. The security should be specific enough to understand what's running on that instance and be able to take advantage of knowing a little bit of intelligence about what vulnerabilities may exist on that system. Is it something that's not getting patches anymore? What can I do for that system? As well as things like integrity monitoring. I know that threat actors will target specific parts of the operating system, whether it's Windows or Linux. And I've got a bunch of flavors, so I hope you can put something in there that takes a look at what the OS is, what applications are running on it, and sort of advises me on what the best protection is. So complete security for Windows and Linux, not just anti-malware, but other things like file integrity monitoring, vulnerability shielding, and some other things I'll get into in a bit. Secondly is scripting and automation. The system has to be set up such so that there is a rich set of APIs that I can interact with. So I have developers that may want to pull some information out of the system. I don't want to have them necessarily have to go to the GUI, to the management interface. I'd like there to be a way to do that with code. With automation, we use Ansible, we use Python, PowerShell. We would like you to include all of those capabilities and give us the ability to script not only, and most importantly, the initial installation and deployment, but other things as well. And some of that is going to have direct integration into AWS, and I'll explain that. Vulnerability management. Again, now Microsoft does not support the older OSs. This particular state agency had hundreds of legacy applications running on older versions of Windows Server that are no longer supported in terms of patches from Microsoft. So what do you do then? Because threat actors know that many agencies, many corporations, many federal agencies are using older Windows operating systems because they're running legacy applications that just can't go away. And there's really no time or no effort behind them or no desire to upgrade. They want them to stay put the way they are. So what can be done then? Part of what protects a cloud instance or a physical server or virtual server is host-based IPS. And what that module will do is it will inventory the operating system that it is running on, that the agent is running on. And it will also look at the applications that are running on that instance or server and figure out, okay, what are the open vulnerabilities here that have not been patched? What I'm going to do with those is I'm going to give you time to patch. And in the meantime, I'm going to put an IPS filter in place that prevents any exploit of that vulnerability. That is a huge thing for servers, for VMs, for cloud workloads, because they're running on the older OSs. They're not going to get patched, and they are a very, very high target and easy target if they're running, if they have vulnerabilities that have not been patched. That's really a very simple way of getting in, exploiting the system, and then running amok once you're in there. So having that host-based IPS capability is not only critical, but being able to put something in place to prevent an exploit of an open vulnerability while there is now time to patch that system is just as critical. Patching takes a long time. We know that not everyone is on a very short or efficient cycle, right? So something to put in place to protect against exploits of vulnerabilities, very critical. The eventual goal was to go to containers and serverless here. So we're starting out in the cloud with EC2 instances, and as those get spun down and there's a move in the DevOps world to go to coding, the point will be that containers start to take hold, and we're going to need something that can not only secure the instances that, let's say, the Docker engine is running on, but we also want to take a look at the network traffic going between containers. And oh, by the way, if you can help us secure the containers themselves, to scan the images and the layers in the images, that's a bonus too. So that's the end goal. The first piece of this going forward would be the EC2 instances, and then a move towards serverless and containers later on. So looking for a solution that can not only help us today, but that can grow with us tomorrow as we make this move into the DevSecOps world. APIs. Again, for being able to write code, developers love to interface with an application, not having to use the GUI, the management GUI itself, being able to pull out data, make queries, change settings, all of that done with an API. And tight integration with AWS, of course. So the move not to use EC2 instances as databases, but rather go to RDS. For the initial implementation and deployment of an agent, being able to drop a script into an AWS instance configuration And so that script, when the instance is spun up, that script will cause the running of this program, which will install the agent and will immediately start protecting with a policy. So all of those things that can be scripted and automated and inserted into the build of an Amazon EC2 instance is really going to save lots of time. So those are some of the specific requirements. The particular solution that this customer chose was Trend Micro Cloud One Workload Security. So talking about silos, let's start busting them down. Implementation. So during the implementation phase, the first thing that was put in place once the instance is being protected by the solution, the top critical piece would be the vulnerability management. So again, inventorying that system to make sure that any vulnerabilities in the OS or the applications that are running on that OS are protected against exploits. So host-based IPS to take care of that particular need, whether it's Windows or Linux, no matter what version. Next is the desire specifically for complete and consistent protection and security in a single agent. This particular customer told us that normally to do what they were seeing us do with Cloud One Workload Security would require them to run several different agents. One for the host IPS, one for the file integrity monitoring, one for the standard anti-malware, another one to do web reputation, and so on. So each of these components that would normally take them 4 or 5 agents were now available in a single agent, which could be consistently deployed, whether it was a physical server on-prem, a VM, or a cloud instance in AWS. Scripting and automation, a big one, as I'd mentioned before. This customer is a big user of Ansible, PowerShell, Python, AWS instance scripting, again, to help with that deployment. So all of these things played very well into their frame of mind, which was not just don't give me the security, give me a way to interface with the security. That doesn't mean I have to bring up a management GUI. I've got plenty of, I've got big teams that love to code. I'd like to release them and let them at it and allow them to be able to pull information out without having to go into the GUI itself. And lastly, of course, certainly not least, in tight integration with AWS. So as I mentioned before, the initial configuration involved EC2 instances with the goal later on of going to EKS, ECS for containers and serverless, small web applications that agencies would upload files through and would get stored in S3 buckets. How do those things get scanned? Is that something we can help with too? Sure. So putting something into that flow as well that doesn't even involve an agent, but rather APIs and code. CloudFormation templates. A big part of this is setting up the initial infrastructure. So making that as simple as possible was a very specific requirement. So running the CloudFormation templates, setting up all of the initial infrastructure, and then let me focus on creating my policies and disseminating agents and the protection throughout the environment. And moving the EC2 instances that were serving as databases to RDS instead. So after all was said and done, the customer shared a bunch of lessons learned with us that I'd now like to share with you. Number 1, take your vendor's guidance. Best practices guides are there for a reason. Professional services teams are there for a reason. You can imagine, as was the case with this state agency, there were a number of different agencies at play throughout the state. They all have different procedures. They all have different skill sets. They all have different development going on, different requirements. But building this kind of complex system, bringing everyone together, requires a lot of architecture review, and that's what the vendor, having had lots of experience in those types of environments, can afford you. So the first lesson learned here was taking the vendor's guidance and accepting it, and the advice as well. The architecture is so much more smoothly laid out when you can co-develop the solution together rather than just one way. Secondly is consistency is king. in these types of multi-agency, multi-team environments. Because again, everyone has their own set of policies they want to deploy. Everyone has their own hierarchy of political stuff. Everyone has all kinds of different things that need to come together. And the ability to deliver a single agent that can protect one agency's on-premise data center while another agency has VMs galore and another agency has multiple AWS accounts, and they need to bring them all together in one console and make all of that security consistent is critical. And that is very important when you're talking about multiple agencies, multiple groups coming together to make something happen. And lastly is bring in the white glove treatment, especially for non-standard environments. So what does that mean? There are teams, there are professional services teams, there are deployment teams. A number of times we will visit with customers who either don't have the staff, or their staff are overworked or over-prioritized and don't have the capability of performing some kind of function within this whole implementation, whether it's the deployment of the agents, whether it's a best practices configuration, whether it's initial policy creation. All of those things can be taken advantage of with a company that can deliver those kinds of professional services and help, making sure that the first time this environment is stood up, it's stood up correctly, it's stood up efficiently, and we're offering the best security foot forward that we possibly can. So taking advantage of that white glove treatment, very important as well. So thanks for watching this session. Again, my name is David Abramowitz. I'm the Regional Tech Lead for our Mid-Atlantic and Federal in Trend Micro. Feel free to reach out to me. It's David_Abramowitz at trendmicro.com, or visit cloud1.trendmicro.com to learn about the solutions that were put in place for this particular project and that are also put in place for many other of our customers. So thank you to AWS for allowing us the opportunity to share this lesson learned, this customer use case, and wishing you all a successful conference.